Today I'm going to go through Lesson 2 in High Adventure Science Plate Tectonics module, Interpreting Earth's Clues. I'm going to try to go through this quite quickly. I'll show you how to do everything, and you should be able to do it on your own. So, starting with the home page of it, Interpreting Earth's Clues simply says we're going to take a look at features on Earth and how they're created by plate interactions. So I'm going to begin activity. You should follow along on your own as I show you this, and you can pause it as you answer questions. So first, there's a video on here. I want you to go ahead and play that. I'm not going to play it for you because I'm creating a video and it doesn't work that way. It'll remove the oceans, and you can take a look at what some features on the ocean floor look like. Okay, I'll click next. So you should have paused this video so you could watch that first one. And we're going to focus on today, how did the Andes Mountains form? The Andes Mountains form the longest continental mountain range in the world. If you don't know where the Andes Mountains are, they're located right here on the west coast of South America. So we're going to take a look at a geographic profile. We take a look at this profile. Here's the picture. The points P1 and P2 correspond to P1 and P2 on the graph. I'll zoom into the graph. You can also take a closer look. The x-axis shows distance in kilometers between the 2 points. All right, that's the only thing it's measuring distance of. And then the y-axis shows elevation, with 0 being the ocean surface, so that's sea level. And then negative numbers are below sea level, positive numbers are above sea level. Okay. So the questions are right from the graph. At what point on the geographic profile does the land elevation rise above sea level? How far from point 1 is the lowest point on the geographic profile of the Andes? And then look at the 670 kilometer mark on the x-axis. What feature might be represented by this elevation? So once again, you're using the graph to determine distance to where the land goes above sea level. You're wondering what's happening here at the lowest point and what that might be. You're not required to know what that's called yet. So now we're going to take a look at this graph called Seismic Explorer again. Now you can see I'm accidentally zooming in and out of it, and that's not a big deal. If you accidentally change something, remember, go to this box with a little dot in it, click that, and it'll take you back to where you're supposed to be for this. It says, first you're going to investigate earthquakes. Use the data type menu to show earthquakes and volcanoes that have happened in the Andes. To show earthquakes, check the earthquakes box and press the start button. So let's take a look at the first question. First, it says, in the relief map, I'm going to go ahead and get rid of this snapshot. What color is the deepest part of the ocean floor in the relief map? So this is the relief map. Is it blue, light blue, or dark blue? Now you'll remember from your thing earlier, this is the deepest part of the ocean floor. So you should certainly answer dark blue for that one. Then it says, take a snapshot and label something called the trench and the mountains. Well, when you do that, you'll see that. You can do it up here on Seismic Explorer. And you're going to go ahead and take a snapshot. So I'll replace the snapshot here. And then I'm going to just use my, click on this, and you can use your stylus to indicate where the trench and mountains are located. And then click done. Describe the patterns of volcanoes in the Andes. All right, so we've got a click on map type. I went off the grid here again. And I'm just going to click that to recenter it. Map type, data type. Okay, and this was volcanoes and earthquakes. So I'm just going to go ahead and plot both of them and X out of this and then hit start. So the pattern of volcanoes and earthquakes in the Andes Mountains, I believe is what it said. The first one said just to do volcanoes. So I'm going to go back to this and I'll stop data type, just volcanoes. So I'll uncheck earthquakes. And then we have the volcanoes here. So there are the volcanoes in the Andes Mountains. You can see that they're forming, they seem to be a line along the western border of South America. So describe the pattern of volcanoes. Then you're going to click play for the earthquakes. And what we're going to look at is how deep are the earthquakes. I'm going to do that real quick. I'll show you where the key is. Back to the map. Sorry. There we go. Now, in my data type, I'm going to switch real quick to earthquakes and put the continental names on there and press play. And mine has already played, so it has everything on there already. So here's a key. Come up here, press key. Once again, the depth now is shown by color. The most shallow ones are red, orange, yellow, green, dark green, and blue to the deepest ones. So you're going to look to see what colors are represented, and then you're going to check all that apply. Based on the Seismic Explorer, how deep are the earthquakes that have occurred in the Andes? Next. This is a video on how to do a cross-section. You should watch that video. Again, I can't show it to you. It doesn't work on WeVideo. But this does have you create a snapshot. Create a cross-section on your screen. And you're going to do a cross-section. It wants you to do the cross-section in the same area where this line was. So I'll show you how to do that. That line right below where South America kind of curves. I'm going to estimate kind of where that is. It looks like it's to almost the center of the continent from off coast. So I'm going to find this map. I'm going to draw a cross section. If you look here in the lower right, click draw cross section. It looks like that's going to be right around here somewhere. Okay, so I clicked it. I dragged with my other finger, and then I'm going to let go. Oh, I did something wrong there. We'll try that again. Okay. And open 3D view. Now this is going to show a cross section, which is if you could cut in between there. And what's nice is it's showing a cross section of that area of South America. I'm going to recenter this. It's in the wrong place over there. But you can see how this on the surface there's the Andes Mountains that we were looking at, volcanoes. But look at the pattern that you see here. You can almost envision a thin section of Earth's crust moving downward. And so what's happening here is you've got earthquakes deeper, deeper, deeper. And as you go inland, they get deeper and deeper. So that's kind of a key point there. You can almost picture something that's there, the shape of something as you move that around. I'm going to scroll to the bottom. And now it says, when you draw the cross section, try to make it in the same place as the profile and take a snapshot. So I'll go ahead and replace the snapshot. And then I'm not going to do any labeling, but you can label. It says to draw a picture of what you think the pieces of Earth are doing as they come together beneath the surface. So once again, this section is moving towards South America, and South America is moving the other way. What might you look for in another place on Earth to know if the surface pieces are moving toward each other? Okay, that's as far as we got for day 1. I'm going to continue the video for day 2. Deep ocean trenches. Trenches are an important piece of evidence to help us explore where pieces of Earth are moving toward each other. So we have the Andes Mountains, and we have the trench located here. There are long, narrow depressions on the seafloor. These oceanic features are the deepest parts of the ocean floor. In the profile, you can see how deep it is. Okay, so that tells you about trenches. Now we're going to take a look at something called the Aleutian Islands. If you don't know where the Aleutian Islands are, they're those islands up here where Alaska kind of curves around here. You can see on this view that there is a trench, a deep trench on the south side of the Aleutian Island chain. And so we've got P1 and P2 again. We've got a geologic profile here. It says, question 11, what evidence would tell you if two pieces of Earth's surface are moving toward each other? So try to come up with evidence as far as earthquakes, possibly volcanoes or mountains or something like that, and I'll move on. So here's the profile of that area. So P1 is over here, and it's deep on the ocean floor. Then all of a sudden, it drops off to a trench, and then it moves up, and you get these little islands forming, and then it's underwater again. Question 12, at 530 kilometers from P1, the geographic profile shows an island above the water. Based on the geographic profile, how tall is the island from the seafloor on the right side to its peak? So for that one, the seafloor mentioned is on the P2 side, they're saying, to its peak. So determine the depth that this is. You can see that this is somewhere a little less than 4,000 meters, maybe 3,800 meters from there. And then it goes to, doesn't show, maybe 200 meters high. If we figure everyone's 200, it's not labeled. So what would the total be? Now that we know what the profile looks like, we can use Seismic Explorer to investigate what earthquakes and volcanoes have happened. Select data type, earthquakes and volcanoes, and the relief map. And then we go to this, and we're going to answer the question, are there volcanoes in the Aleutian Islands? Well, I'm going to go ahead and click on data type, volcanoes, and I'll go ahead and hit start. Well, yes. I mean, I think that answers your question. How deep are the earthquakes in the Aleutian Islands? You're going to select all the correct answers. So I'm going to stop this now. Start over. Data type. Let's choose earthquakes. And go ahead and put the continent names if you want. And we'll hit start. And that's showing the earthquakes. Now we're going to need to know the depths of the earthquake. So I'm looking. I'm going to use the key. Do we have red ones? Do we have orange? Do we have yellow? Do we have green? Do we have dark green? And do we have blue? We're looking at the Aleutian Islands right over here. Okay, this chain here. And you should answer the question, how deep are the earthquakes that have occurred in the Aleutian? Correct. Select all correct answers. Next, you're going to create a cross-section of the earthquakes that's in the same region as that P1, P2 line like we did before. So go back up. That line is approximately right through the middle there. I'll see if I can possibly put it in the right place. I'll draw a cross-section from here to here. Let go, open 3D view. There it is. Take a snapshot of your cross section. So I did that. I'll take a snapshot. Done. What would you look for in the geographic profile and earthquake and volcano data to know if two pieces of Earth's surface were moving toward each other? What is it that you'd look for in that picture then to support that idea? Oh, we missed number 16. Sorry. Describe the earthquakes you see in the 3D cross section. Okay, describe, right? Based on where the earthquakes are, what do you think is happening when with the two pieces of Earth's surface? What do you think is happening there? Okay, I'm going to click next. We are on the second to last page. This is where we're taking a look at crust. Continental, oceanic, right? Continental crust is thicker, oceanic crust is thinner. Oceanic crust is more dense, so it tends to sink, whereas continental crust is less dense. So what this says to do is you're going to use this Tectonic Explorer, and this one only has 2 plates, it says, and it tells you how to do it. Go ahead and press play on the video to explain how to create continents in there. Again, I'll let you do that on your own. Add forces to the plates. Choose which plate will go under the other, and so on. So you should create a continent that looks like South America. And so I'm going to do that. Draw a continent, South America. I'll look something like, I'll make it kind of big so we can kind of see things. That's probably good enough. And then I'm going to use arrows. Sorry. I'm going to go down here and click next after I draw my continent. Assign forces. So I'm going to show this is moving this direction, and this plate's moving this direction. We're going to show what happens when they collide. And then next, I'm going to order the plates. Which one should go on top? Which one should go on the bottom? Well, the continental one should go on top. So I'm going to drag that over to put it on the top, and then click Finish. And now it's going to show what happens. Well, what you see happening then, of course, you got the Andes Mountains forming and so on. So take a snapshot of the model and cross section. So let's draw a cross section. We want a cross section right through here. Okay. There we go. We have a model and a cross section. The cross section shows an oceanic plate getting shoved under the continental plate. Take a snapshot of that. Describe how the plate with only oceanic crust and the plate with continental crust moved to form a mountain range. So what happened there? And now set it up to match the Aleutian Islands in a way that creates a chain of islands. Now the Aleutian Islands, you wouldn't have any continents drawn. They're just 2 oceanic plates. Okay, so if I were to do that, I would figure out how to reset this one right here. So I'm going to go ahead and restart, reload. There we go. 2 oceanic plates. I've drawn the continents next because there are no continents for this one. Assign forces, the Aleutian Islands. You have them moving toward each other, 2 oceanic plates. Next, doesn't matter. One will be subducted under the other. Finish. Now you'll be able to see what happens. We'll let it run for a little bit. Some islands are forming, we can see, so I'm going to go ahead and stop. There's an island chain, and now I'm going to click draw cross section, and we'll draw a cross section to see what's happening here. And there it is. Okay, answer those questions. Click next. The last one, how did the Himalayan mountains form? So the Himalayas form with 2 continental crusts. So we're going to let this go ahead and load. Here's India. You can see India moving toward Asia. India runs into Asia. India keeps running into Asia, causing the Himalayas to form. So now we're going to do the same thing here. We're going to let this run longer. On the wrong thing right here. I'm going to let you go ahead and do this when I see that I'm running out of time. So what you're going to do, we can add plate boundaries and stuff. I'm going to X out of that. I'm going to close this. I'm going to click Start. Okay, so what's happening here? This is while India was approaching Asia. And so this is a long time ago. Okay, tells you how many millions of years have passed by. Himalayas have not formed yet. So what we're going to see is when the continent then runs into Asia, I'm going to let it go here. Now we see mountains forming that are going to become the Himalayas, including Mount Everest, the highest point on Earth. Okay, I'm going to go ahead and press. It looks like it's pretty slowed down here. Stop. Draw a cross section. You want a cross section. Not the best area there. I might do a different one if it lets me. It tells you, right? It shows you what's happening as the two are colliding. Maybe you can do a better one. Okay. Describe what happens in the model between the beginning and 160 million years as you watch it, and then to about 190 million years, and then you're done. So lesson 2 is quite long. Good luck. Let me know if you have any questions. It's 25 points, and email me when you turn it in.